He's just. What, were you going to add something else there?
Welcome to Learn Math with Brian. Today, streaming.
Well,
Today we're streaming.
well, we're always trying to stream. We're doing this twice a week, as we always are, or whatever. So good to have you here, folks.
The last time at the end we tried Sonic.
Well, we tried. Yeah, which now you got Sonic on your shirt or whatever. Okay, there it is.
Hope you get this shirt.
So. All right.
Sonic.
Oh, jeez, he's already starting, folks. Good to have you here, folks, for another live stream of K-12 math. Anything you guys need live help on? Before we start, and while he's getting his mess on or whatever, I'll just point out real quick that as I indicated in the description in this video or whatever, that this is going to be, we are entering our final 2 weeks of these live streams here. We're going to be here this Tuesday and Friday, and then next Tuesday and Friday, and then that's it. Part of the reason why for that is I am personally aware that I know that many states around the country do not behave in the same way that we here in Jersey, because we go like to late June and stuff like that. But I know there's a lot of districts that are usually ending kind of around this time of the year and stuff like that. And thus go back a couple weeks before Labor Day in August and stuff like that.
Guys,
so to make up for that balance in time, so we're going to cut ourselves off at that point.
I hope you see like the new movie that's coming out on May 15th.
What?
Scooby.
Oh, is that okay? All right, enough. You with the plugs and stuff like that. Okay, so we're gonna get to our business here. All right, because in the meantime, we're still here. Any help you guys want in K-12 math, please submit. The live chat is right there. Get us started with some topics while we ad lib on some stuff here. If there's anything you guys would like to see. And at the same time, brian.sapinski@gmail.com. You could send up right there. I got my phone on me, so I will keep on standby with that as well. Okay, now Joe, you keep pushing the board here. We gotta move this up. Okay, so
Nice.
Oh God, Brian is out here on the side. So no, all right. Can you get the rag and lift the rag?
Oh, good Lord, that's so
bad.
creepy.
Okay, get the rag. I forgot to get that all in there, stuff like that.
I'm gonna do it one more time.
All right, so that's the start. All right, Joey. No, we got business to do.
Okay.
Come on.
But can Mr. Dice join in?
We got in a minute. We'll get him set. All right. I know you've been busy with some stuff, Joey. Okay. I know you've been busy with some math that looked something like this today. You were doing additions that wanted you to do things like this. Okay? And what he was okay, all right, well he's here, he's fine. I told you not to do that.
He wants to join in. Look.
All right, okay, so he's right there. All right, but Joey, I need you to join in. Listen.
I already joined in.
All right, okay, but I need you to focus on me here, because you got a task in front of you. 14 plus 8, buddy. Okay, so here's what he's had to do. Okay, Joey, we know that with 14. We know that with 14, you have. We know you have 110. Draw the ones. Draw the ones, Joe. Joey, draw the ones. Draw the ones. No, don't put the marker down. Draw the ones.
Okay.
Make the ones for 14. So I made the 10. You make the ones. Okay. Now, what he's been trying to do these last couple of days is that his object is that in trying to add these, they haven't discussed the idea of carrying yet in first grade. I assume he's going to see it later. But for right now, what they've been talking about, and it's always a good addition strategy for a lot of you guys, especially if you're in later grades and are still having, messing up additions and stuff like that. Always important. Try to make tens wherever it is that you can. So here, Joey, draw out the 8 tens. Draw out the 8 ones for this. Draw out the 8 ones for that.
1.
Here, I'll separate them. Go. Keep drawing down.
1,
Whatever, it's fine.
2, 3, 4, 5, 6, 7, 8.
Now here's the thing. How many of these? Okay, wait. So how many ones do we need to borrow down from here to make a 10 with the 4 up there? Remember what we were doing earlier today? Okay, here's 4. So there's 4 fingers. How many fingers are missing to make 10? 6. Okay.
Like my favorite number.
Okay. So here's
I don't
6. So here's 6 right there. Combined with those 4. So there's your 10. So here's a 10. Here's another 10, Joe. Joey, stay with me. How many 10s do we have now? Here, because here's a 10 and here's a 10. So how many 10s have we got? 2 10s. And how many 1s do we have left over? How many 1s are left over? How many 1s are left over?
2.
So that means we finish with 2 10s and 2 1s. What number is that? 2 10s and 2 1s is 10. What is it? Read the number, Joe. Read the number. Read the number. Read this number.
22.
Thank you. Okay. All right. Do it again. Do it again then, Joe. Okay. What about?
Nice.
What about this? Okay, Joe. Do it. All right. Do this, Joe. Here we go. 37. 1, 2, 3 10s. Make the 1s. Make the 1s. Go. Make the 1s here.
1, 2, 3, 4, 5, 6, 7, 8.
No. Just 7. Okay. Now make these 1s. Make these 1s down here.
1, 2, 3, 4, 5.
Okay.
6 and 9.
Here's 7. How many of these 1s do we need to add to 7 to make 10?
1, 2, 3.
3 of them, right? Yes. Okay. Because here's that. Okay. So count your 10s, Joe. Count your 10s again. Count your 10s. Joey, come back to me. Count your 10s. Here's 1,
2, 3, 4.
4 10s. And how many 1s left over? How many extra 1s? Joey, how many extra 1s?
3.
So what number do we get?
43.
Okay, he's got that covered, folks. Okay. You just got to get him off what he's trying to do and just get him to pay attention, and you're all set. And you wonder why his videos require so many, have so many cuts in them, because we have to take so many times. But nah, he's good though. We just needed to get in one continuous flow. Yeah. Okay, you know I love you. All right. Oh, that's there. Okay.
Hey, not erase.
So we got those. Okay, now Joey, I got a little bit of an extra challenge for you. Okay. As I'm getting an odd message here on the side. Okay, I got a little bit of a challenge for you here, Joe. Okay.
Yeah.
You've done this.
Can they do it too? Can the guys? Oh, guess what? They have a baby. They had a baby. Now they have a little baby toys.
Okay, here change this up a little bit. Okay, want to do that a little better.
Look,
Okay.
it's little baby toys.
Okay, very good. All right. Okay. We got a question. Okay, explain tangent. Okay, all right. Okay, we got a little bit of a geo question here while Joey's off in his own world. Okay. All right. So tangent. All right. Let's fly the national flag of Sokotoa.
Really?
Okay. We fly the national flag once again there. Okay, that's fine. All right. So here's the deal. All right. So tangent. So that you're focused on this part of the Sokotoa. I can tell it's probably one of my students because I had a number of trig questions come up in the last few days. Okay, Tangent referring to the opposite side over the adjacent side. Okay, what that essentially means is this, and I'll show it from two. I'll show it from two different.
Mr. Dice sent the message to us. It says, "Oh."
I'll show it from two different perspectives here, depending on whether we're focused on our angle of elevation, depending on whether our focused acute angle is either over here, down here at the bottom corner, or whether it's up here at the top corner and stuff like that, because that's going to change things or whatever. So the OA standing for opposite over the adjacent.
Even the baby Dice sent it a comment. It says, "What the heck does that say?"
Good, Joey. Shh, come on. So here's the deal.
Anything?
The first thing you have to do is you have to know, depending on where your angle is located, you got to know where the opposite and the adjacent sides of the triangle are. Now, the one side you definitely know in any right triangle is going to be where the hypotenuse is. And in both of these triangles, that's the one fixed position. The hypotenuse is right there and there. So the thing is, for the tangent does not require the use of that particular side. So that we ignore. So this one we ignore altogether. That means we're focused on the two legs. So the thing you have to understand is that the opposite is a leg and the adjacent is a leg. So the hypotenuse is not included. But now it's a question of, in each case, identifying which is which. Which one is opposite from your angle and which one is adjacent from your angle.
Mrs. Dice sent us a comment. It says good.
All right, fine. So now, in identifying the two, all right, sometimes now everybody's got their own. Okay.
Look, the Dice family.
Okay, bear with 1 second. I thank you for asking your question. Oh wow, excellent. Glad you could join here or whatever. Oh, guys, hello. Wait, listen. Shh. We're international here right now. Okay. We got somebody from the Netherlands asking questions here. Okay. So we've got to I got to try to explain this as best I can. Here, let me spell out the name of this in full here. Okay. All right. And here, Joe, I'm gonna need a favor from you, buddy.
Well, the one that's older gets
okay.
the crown. No, they don't.
Okay. All right, guys.
They get the hat.
Shh. Okay, guys. Very important. Okay, here, Joe. Have a seat for a second. Take a pattern. I'm glad. I hope we're amusing you there. Okay, so as I was trying to say, okay, this one particular side here, okay, yeah, this is the name that's used for it. It's called the hypotenuse. Okay, I apologize if it's I know it's a very strange word. I understand, but that's literally the name that is given to it. So I apologize. I can't make that particular word any bit simpler. Okay. Now the idea is then with these other two lines that make up the right triangle, because you have the right angle that's right here. Okay. This is the right angle. Use that box to indicate it. That means it represents exactly 90 degrees. Okay. These two lines are line segments. Shh, Joey, talking over me. Don't do that. These two line segments that are connected, that are touching the right angle, we call these the legs. This is a leg. This is a leg. Same thing down here.
Smiley.
This is a leg. This is a leg.
I'm calling the
now.
Smiley. Oh look!
In addition to calling these,
Mr. Smiley is in space right now.
Okay, here. You chill in space over there for a minute. I'll tell you when I need you next time. Okay, so in addition to calling both of these legs, what you see is that there's an extra name that you could use to describe each of those two particular segments. Okay, we call one of them the opposite side, or the opposite leg, and the other one we call the adjacent leg. Adjacent is a fancy way of saying next to. Okay, so I hope that much makes sense. Now, the question is, identifying which is which. So trying to do that, what's going to be important about that is you have to look at where your angle is marked or identified. Okay, so here, let me give you an example. Let me put some numbers here in these positions instead of x. Let me give it some actual numerical context. Let's say, for instance, this angle right here, angle A. Let's say it had a measurement of 40 degrees. Okay, fix my 4 there. There, that's better. Okay, so let's suppose that you had that. Now, let's say that, okay, this line segment that's down here.
The dice is like sending us a message. It says you are good.
Okay, well, I hope you are. Anyway,
me too. I'm good.
This leg that's sitting here. Notice that this line here is touching the 40 degrees. So the fact that this line is touching and sitting next to 40 degrees, that would make this the adjacent leg. Okay. So that's what would happen there. And now there's going to be a measurement that's going to be connected to that in some way. Let's suppose that this had a measurement of 10. Let's say, for example, it could be 10 centimeters, it could be 10 inches, it could be whatever happens to be for the context.
And it's really random.
Okay, so
it's really random.
Okay, all right, Joey, somebody is asking me questions here. I need you to chill. You got to stop.
I don't know what that says. Guys, does Mr. Dice know?
So now that leaves this other leg. This other leg would be considered the opposite leg.
I know it.
Okay, this one will be the opposite leg. This line. Now, Now, the reason why this would be considered the opposite is because from where this angle is located, okay, again, this angle A is sitting in this corner right there. If you follow these two lines open up to make this angle. That leaves this one line remaining. This third line of the triangle is in no way part of this 40-degree angle. It's not used to make it. It's just sitting completely on the other or opposite ends of the triangle. So hence why we call it the opposite leg. Now suppose for a minute that I did not know what that measurement was supposed to be. I'm gonna put an X here to represent that. So the way we would try to find this value is, since we have an opposite here and we have our adjacent here, that means that these combined will make a tangent equation. And here's how the actually I'm in New Jersey. I'm in America actually. So, and you want to know something? I'm gonna tell you that, and I'm being completely honest here when I say this. Okay, years ago. So I'm going back about 25 years or whatever. When I first got into college or whatever, for some strange reason, people that I first met when I was going to college thought that I had an English accent, and I had no clue why that made any sense. That made no sense to me. I have no idea how they sensed from the way I'm talking that I was from England when I'm actually, like said, from New Jersey and things like that. Because
I love England.
Yes, I know you love England. I know.
From DANTDM.
I know you like Dan TDM. I know he does. So anyway, well, like I said, I'm good with mathematics. I'm here pretty much all day with it. I mean, granted, if there's a physics problem that you've got or something like that can be related to some type of mathematical formulas, I can easily present it here if you've got good ideas or whatever. But here, let me finish this one because we're not quite settled on this one yet. So here's how the equation would look. Since you have a 40-degree angle, you would want to calculate whatever tangent of 40 degrees happens to be. Now again, this whole OA, this opposite adjacent thing. That's actually a fraction. And the idea is that the measurement of the opposite side goes over the measurement of the adjacent side, like that, okay? So in this case, I don't know what the opposite is yet, so I would put an X right there. I do know the adjacent, though. The adjacent I have is a 10, so that would go right there. So this is the equation that you would put together to try to solve for X. Now, you have to look at this from a simple algebraic standpoint. You have X or some unknown number divided by 10. And that has to equal whatever decimal this whole thing comes out to. We'll get to that in a minute. The thing is that to get rid of this division of 10, you need to perform the opposite of that. And whatever opposite you do that gets rid of this division of 10, you do that same thing to the other side. So here, Brianna, sitting in the back there. Again, to reverse division, we need to do what? Okay, that's my daughter back there. You'll see her in a minute if you haven't already. So I would multiply both sides by 10. That would get rid of this altogether. But what I do to this side, I have to do this side also in order to keep the equation balanced. Okay, so now I've got 10 times the tangent of 40. And whatever that gives me, that would be the final actual measurement of X here. Okay, so I'm going to plug this in. This is going to be one of those topics that's more calculator dependent. So if you've got a scientific calculator on you where you could write this all out on one single line, it would help you out a lot because then it'll give you exact numbers and things like that. So in my case, I'm going to plug in 10 tan 40, okay? And it ends up coming out to, as you can see it right there, it comes out to about 8.39, or if you had to round it to one place, 8.4, whatever the necessary rounding happens to be. So we'll call it 8.4 for now, and that will be your official measurement. Okay, so that's essentially how tangent works. Now, the only other thing you just got to watch out for is, again, which one you call the opposite and which one you call the adjacent. Because here, the classification was like this if the angle was down here. But if the angle was up here, instead, then that angle would open up down to here, making this one the opposite. And then this leg is touching or sitting next to the angle. That would make this one the adjacent. And so then whatever numbers they have, you have to interpret accordingly from there and stuff like that. So again, just to throw an example out there, if you had, for instance, again, let's suppose we had a degree measure here. Let's say there was a 20 degree up here, just for example. And let's say, again, here's your adjacent. Let's say there was a 12 right there and you wanted to find the opposite. It'll be the same kind of thing as what happens up here. Your opposite is X. It goes on top of the fraction. Your adjacent sitting next to the 20 is 12. That would go at the bottom. And then, since you're using those two, that again requires T for tangent. So it would look like this. And now the same thing that happened on this one, you would do this one, where to get rid of the division of 12, you would multiply both sides by 12. So we plug that in and see what it says. 12 times tangent of 20, and we get a value of X of approximately, just to prove it there, of about 4.4 when we round it off to one decimal place. Okay? So something in that particular nature. Now, how you solve these equations, they could change in some cases depending on where the X is located, because like in both of these, I put the X at the top of the fraction. I set it up where the opposite leg had the X. But there are some times where the X could be over here on the adjacent, and there are other times where the X could be the angle itself. Oh, okay. All right. You're segueing right into that very last thing that I just said. Okay. Because, all right, what if okay, what if instead, let's say we don't know, okay, I'll change this one up a little bit. Let's suppose that, let me get this out of the way because we don't need this. So like, let's suppose here, I'll keep the 12 just for a minute. Let's suppose that the tan negative 1, okay, here's an example of what that looks like. Let's suppose again that you know the adjacent, and let's say you also know the measurement of the opposite leg. I'm going to throw a measurement out there. Let's say, okay, I'm going to put okay, all right, how's about a 20 right there? Let's just say. Now, in a case like this, what I don't know is the angle up here. What you do know, however, is that you have an opposite measurement, you have an adjacent measurement. That means you're still dealing with a tangent equation. But this time, you can't, next to tan, you can't put a measurement here because you don't know it yet. Your job is to find it. So that means right now, this is your x at the moment. Now, as far as these, you still got to put the opposite number over the adjacent number. And don't worry if it happens that the opposite number is bigger. Depending on, that happens sometimes. Matter of fact, it can only happen in tangent where the opposite number can possibly be bigger than the adjacent. Okay? So seeing an improper fraction like this, it can only ever possibly happen with tangent. Because in the other two, sine and cosine, you'll never see something like this. The bottom number will always be bigger in sine or cosine because of the hypotenuse. The hypotenuse is always the biggest side in the whole triangle. Okay, I hope that makes sense to you. So here's what we have happen here now as a result. To get to the angle measurement, to get to the degree, you have to eliminate the tan. To eliminate the tan, we're using exactly what you just said there in the chat, the tan negative 1. So what you need to calculate is this, the tan negative 1 of, and I would personally suggest that rather than calculate 20 divided by 12 and get a decimal that you might have to very likely round or do something like that with, I would probably just suggest keep the fraction exactly the way it reads. So I would just put this in exactly as it says and hit the equals on your calculator right from there. Okay, so I'll show you what I mean. So so in my calculator, so I've got to hit that inverse key. So there's that. All right. And you see how now it changes to sine negative 1, cosine negative 1, tan negative 1. So I'll hit the tan negative 1, and now I'll put my division in of 20 divided by 12 in the parentheses and close it. And you can see the amount that it's given me has reversed the trig. It's removed the tangent function and taken me back directly to what the measurement of the angle happens to be. In this case, estimating to be about 59.0 degrees, which would be the official value of your angle x right here. Okay, so that's the kind of thing you've been seeing to reverse the function like that. So whenever they don't give you the angle, but they do give you the two legs, that's how the equations like that would end up looking. All right, so I hope that makes sense to you. I hope that's in there within reason. Here, if you have another question about anything, please by all means shoot it out there. We'd love to be able to help you figure out more, especially with regards to this trig or whatever it is that you need here. That's why we're here doing this. Okay, so here, while you come up with another question, if there's something else that you want here. Okay, here, Joe.
Wait. He has a very important job.
What is he doing?
He's watching water evaporate.
Hey, don't erase them!
I need the space, buddy.
I want to teach him about evaporation. First by showing him, and then he's gonna watch part of a Storybots episode because that's how they explain it. It's the one about rain.
Storybots?
Yeah.
I want watching storylines before.
Okay, you can't see behind the board here, folks, but what they're doing right now is for whatever reason,
rectangle square of
she's
sunlight.
yeah, because we have skylights here in our living room and stuff like that.
Water on part of the floor there,
where the sun is shining down. Now, Brianna, you realize that the sun is not hot enough to make that puddle of water disappear.
You don't know that.
Brianna, that's going to be sitting there for a long, long time.
Okay.
If anything, that's not going to evaporate. The floor is going to soak that. And that's not going to be a good thing.
Oh.
I know what you're trying to do. No, I get it. That made sense.
Should I leave a cup of water there? Should I just leave a cup of water? Joey, don't spread it out.
You got to give him credit for being inventive, folks. I'll give you got to give him that. So
Joey, don't spread it out.
And
Joey, can you get a bigger towel?
Oh God.
All
right. Brianna.
Joey, can you get a bigger towel?
No. Right here, Brianna. Answer this for me while you're back there and stuff like that, okay? If I, with a better marker anyway, if I asked you, Brianna, what the heck is this? It should not be like that. The thing that should not be. Okay, if I asked you to take these numbers, Brianna. All right,
no.
Brianna, real quick. If I asked you to organize these numbers from lowest to highest, okay? No challenge there, right?
Yeah, no.
Okay, so from lowest to highest, what would the numbers be? Just tell me. Just tell me. Okay, fine. Okay, 4 would be the lowest, 35 mil, and 25 would be highest. Okay, that seems straightforward enough, right? Okay, Brianna's been doing a lot of work with decimals recently, and last day or two, she's been faced with this challenge, where instead of it just being plain old regular numbers, regular integers like these, she has been presented with numbers that look like this. Okay.
Sorry about that.
Now, Brianna.
Yes.
Now look at these decimals as the chaos continues behind me in the room here. Now look at these decimals, Brianna. Which one? Now put these in order. Put these in order from lowest to highest. Or here, Joe, you want to try it here? Put these down.
No. Okay, I will. Joey, you say you want to pour more water onto the floor and then just go.
No, I want to do.
So 0.35, 0.4, and 0.205.
Wait, what was Wait, what did you Oh.
Wait, you got 0.35, 0.4, and 0.205. Let's see how this one goes.
The numbers here. Joey's going ham on that puddle of water.
Okay, and if
you add the zeros to it.
Exactly. Yes. Okay. I was about to get to that very explanation.
The finest chicken scratch in all the world.
No, mine's the finest chicken scratch in all the world. Everybody knows that. So you may comment on your handwriting, Hans, if you wish to. So yeah, please, absolutely. I would love to. No, I know what you meant. Please, by all means, I would. Please, I want to be able to help you guys, anybody, as much as I possibly can. So please, by all means, yeah, please send me around and.
Hey, Joe,
and
I'm gonna
have
have
him
water.
join in this broadcast while we still have some time. Or my next broadcast is Friday again at 2 p.m. Eastern Daylight Time, Eastern or New York time and stuff like that.
Yeah,
So,
Joe, I need to.
all right, but let me explain the reason for this.
Yeah.
Okay, well, let me explain the reason why
Joey,
why
there's
this is
another way
true.
we could look at
Because a lot of people
evaporation.
would think, but wait, this has so many more digits than that. Why is this smaller than this? It has to come down to place value, as Brianna correctly showed. Because when you're comparing normal numbers, okay, when you compare the original numbers that we had in the first place, and no decimals, if you look at this, when you look at everything from a place value standpoint, okay, you could line up everything by including zeros. In this case, you include zeros in the front. You have to then go from left to right to see what's bigger and what's smaller. So comparing these, this is the only one that has hundreds. It has two 100s. Therefore, this is the largest in terms of value. Then going through the next place value, now between the remaining two, 3 beats 0, so that means this would be second, and then by default, this is the smallest. So that's the story there. But that same rule of place value takes place when you're dealing with decimals. But a lot of people automatically think that, like I said, that 205 is bigger than 4. It is, but that's on the left side of the decimal. On the right, again, you have to consider place value. So if it helps you to add extra zeros to the right so that you see the same number of digits to the right of the decimal. So now when you compare them, out of these three, 2 is the smallest decimal in the 10th position. So that means this one is now the smallest. The 3 would be next in ranking, and the 4 would be the largest. So that's the kind of thing that Brianne was looking at. Okay. How to do log on the calculator? What is the reason why you have log of -1? Okay, let me see something here. Do I have log of -1 on this calculator? Let me see. I don't know if I have log in this calculator. I want to see something. Okay, well, I know what the inverse whole idea of a logarithmic function is supposed to be. Okay. So, okay, yeah, I'm done with the decimal example, so I can stop with that for a moment. Okay, so here, we'll leave the nation of Sokotoa for a couple of minutes here. So we'll get all of that into position here. Okay, so Hans is asking a question here, and I think we did a little demonstration of logarithmic functions, I think a few weeks ago here on the live stream. But here, okay, you have a Texas Instrument. I know I have a Texas Instrument also. I don't think the batteries in it are working anymore. But as a matter of fact, here, let me see. I have an old school blue Texas Instruments. I don't know where it is. Let me see. Do I have it here in my bag? Oh, here it is.
I'm on my computer right now.
Let me see. Log.
I'm on my computer right now. I'm trying to search
Okay,
something.
you see, so here's the traditional TI-34 that I've got that I like to that I usually keep on standby and stuff like that. However, okay, this one doesn't have a log -1 either, but there is still an inverse to the logarithmic function, and you could see it in the business right there. Hopefully, you see where it says 10 to the whatever power. That is essentially the reverse of a logarithmic sentence, because as was asked to me by a local student here in New Jersey a few weeks back or whatever, with some Algebra 2 help that she had. One thing you have to understand is and I'll do this with some general number demonstration, is that if you calculate, for instance, 10 to the third power, that would be the same as 10 times 10 times 10, and that would give you 1,000. That's how you would write, that's how these three numbers are connected in what is referred to as an exponential sentence, okay? Now, To twist everything around with that into a logarithmic format, here's the way all that would look, okay? You would have, okay, log to represent that a logarithm is being conducted. Now, in the subscript underneath the, below, sort of beneath the word log, that's where your base value would be located. In this case, your base is 10. So we would place that there. Now, traditionally, when you're doing a logarithm, I understand that this 10, if you didn't write any number there, 10 would automatically be assumed. So I'm just putting the 10 there just for demonstration purposes, just to emphasize. Okay, so I'll do a couple of examples with some other bases instead, just to further that point. But then the result that we get from 1,000 would go here, and then the exponent from the exponential function would be the result of that logarithmic calculation. So the whole idea is where the exponential function is saying that if you multiply 3 10s, you get this. The logarithmic equation is saying how many 10s do you have to multiply to get this? What is the exponent? So this wants the ends calculation. This wants to know what the exponent is. That's the difference between the two. Okay. So if you were trying to solve a sentence, that said something like this. So if you were trying to solve, let's say, log 3 of okay, I'm just coming up with a number off the top of my head. Okay, 243. I want to pick a number that works for this example. Okay, and it equals this. Okay, what you would be trying to figure out is you're trying to calculate for yourself what number, how many times do you have to multiply 3 by itself to get 243? So in some cases, if you could find an exact number that leads to 243, go ahead and find it. Now, I picked one on purpose that came out to this exact amount there. So if you start doing a times 3 table, okay, the first 3 would, of course, give you 3. And then if you keep multiplying by 3, the next one would give you 9. The third one would give you 27. The fourth one, another times 3 would give you 81. And then another times 3, and there's your 243 right there. So the fifth multiplication of 3 would give it to you. So x would equal 5 in this case. Now, usually you would use this type of problem to solve when you have an exponential sentence that looks like this. When it says that 3 to some power equals 243. No. This would be making this logarithmic sentence would be the inverse of that, and calculating that would give you the solution.
He's crushing me.
Okay. Well, I can't help that.
Hello.
No, you can't.
Well, when 2 sit in a chair.
No, Joey, get off of me.
Okay, all right, guys,
Get off.
chill there.
You get off.
No, you get off.
You're sitting on
How about
top
both
of
of you
me.
move over to the side for a minute?
Joey, get your own chair.
Now, as far as okay,
But please get your own chair.
yeah. Now, as far as entering this into a calculator, most calculators are only going to allow you to either put in a standard log of 10 or put in a natural log of e. The natural log written like this. It's written as an ln in the calculator. Okay, so any other base besides 10 or e, you're not going to be able to naturally put it in. So in order to be able to write in something like this, you would have to use what is called the change of log format and stuff like that, and or the change of base formula. And I'm gonna even remind myself, because every once in a while when I get to this spot, I worry that I'm going to forget exactly how it's going to go. Okay, that's right. So the way you'd have to write this to be able to enter it into the TI calculator to get it to understand would be like this. For any setup, like this or whatever, okay, where you have a log according to some base giving you an end result, it could be translated like this. You take a standard log 10 or log e based on the end number, okay, divided by a standard or natural log of the base that you were putting in, like so. So to translate this, and this is how we'll enter it into the calculator, if I write this in the calculator as standard log 243 divided by standard log of 3, it should still give me the 5 that we found when everything showed. Just give me 1 second here. Yes. Let me just type it in. Just make sure I have not screwed this up. Just make sure, because I always like to double check my work here. And yep, I got the 5 like I'm supposed to get. Now here, this calculator window does not show the entire sentence here. Let me see if my pixel calculator can show the whole bit here, just so you can see what it's supposed to look like here. Give me 1 second. Log of 3. Yep. Okay. There it is. Yeah. So this is how you would enter it into the calculator. That's what you would want it to read from left to right, and you see how it is that it works there. So you could use this type. of change of base formula. That's what it's called. Okay. This is the change of base formula when it comes to logarithms. So you could use that to be able to take any base that you would not normally be able to enter into a calculator to calculate these logarithms and convert it into either standard log, which would be log 10, or the natural log n. Because let's say I use that instead of this. So let's suppose that I put the natural logs in instead. I'll show you real quick that it would still work out to the exact same thing. It doesn't matter what it is what base you use, as long as you use the same base in both cases. And there's your proof right there. It still comes out to 5. As long as the base of the log that you're changing to is the same for both of them, then you just take these two numbers, set them up tied with each other like so. All right. So here I'll do one more example just to further the concept here or whatever. So what if? So let's suppose that you were solving this particular sentence. Let's suppose you were given the sentence. Okay, let's say 4 to the x power were to equal, and here, this time I'm going to pick a number that's intentionally not going to work out to something even, because we have to recognize that many of these kind of problems have exponents that are not uniform. So let's say 4 to some power equals 50. So to solve this for x, I would invert this again and turn it into a logarithmic function. So it would say log base 4 of 50 is this power. Okay. Oh, okay. ln is what's considered the natural log. Okay. The natural logarithm. What it is essentially, it's the reverse of what is considered the natural number. Okay, the natural number of e. And e on its own, for example, okay, whoops, let me clear the board there just so you can see it. E on its own is it's a come on, Joey, come on, stop, buddy. He gets a little too hammy. Bear with me there. Okay, the E, the natural number is it's an irrational number. It's going to appear like it's not, but actually is an irrational number. This is what it amounts to: 2.71828, and so on after that. I will be honest that I don't know what its origin is, what it's based upon, because I don't really see the natural number used in a lot of places mathematically and formula wise. I know it does exist in places, just where escapes me, because I haven't run into those kind of problems very often, just in particular myself. Maybe perhaps for Friday's stream, I'll try to fish up some examples so you could see what it has to do with there.
That's when Scooby's coming out.
So the idea here. So this is the sentence that we have. So now again, I can't put log 4 into into either of these calculators, but I could use the change of base formula and use either a standard log 10 or the natural log based with a base of E, and I could use either of those and set this fraction up and get it solved. So I could either do log based on 50 divided by log based on 4, or if I use the natural logs instead, I could do the natural log based on 50 divided by the natural log based on 4. In either case, the amount for the exponent that I get would be the same. So just to show it there, so log based on 50 divided by log based on 4, okay? And I get an exponent, in this of about 2.82 for that. Do you necessarily need it? No. Again, when you do the change, when you're doing this change of base, what base you choose to use is entirely up to you. I'm just proving here that according to this formula, as long as you use the same base on both top and bottom, you'll get the same answer. So it's entirely up to you which one you want to use. You could do this like we did here and just use log 10 and log 10 on both top and bottom, or just to prove that it works, you could instead do natural log 50 divided by natural log 4, and notice it gives you the same 2.82. So it more has to do with just making sure that these bases match. As long as they match, feel free to use whichever one you like. Okay, so that's the story there.
I have a question.
Shoot, what you got?
What kind of a triangle is the little white triangle in the YouTube logo?
I would most likely classify that as an isosceles triangle, because I would imagine that the two slanted sides of that arrow are the same measurement. That makes them congruent. That makes them congruent to each other. Any triangle that has at least two congruent sides is classified as isosceles.
It kind of looks like an acute triangle.
Well, wait. Acute doesn't have anything to do with how many sides are equal. That has to do with how many angles are equal. You would be right in calling it acute. Here, I'll tell you what. Bear with me 1 second, Hans. We just have a little side question, and a good question nonetheless from a geometry standpoint. So just bear with me 1 second. I'll get back to your question in just a minute. But just to because you have to remember, Brian, when you classify triangles, okay, there's three names. There's two names that you could give any triangle. There's one set of names that you could give it according to its angles. Okay, those being the acute, the right, and
all the sides on the same
and
side?
the obtuse. Hang on, wait, hold on. I'll get there. And then by the sides. The sides is where the isosceles is that I just mentioned, okay? Prior to that, you have a scalene where none of the three sides are equal or congruent. And then you have the equilateral where all of the sides are equal and congruent.
It looks like
Okay.
all the sides are equal.
Okay, well, they might be. They might be in there. But we definitely know that the two slanted ones are. So if the two slanted ones are, that means that it's definitely at the least an isosceles triangle. Okay?
You think all of them are the same size?
Okay, then that would make it equilateral, but understand something. But understand something. Equilateral does technically also fit the definition of isosceles. Because no, a lot of people make the mistake. They think that isosceles means you have to have exactly two sides equal. That's not true.
Two or more.
It has to be at least two that are congruent.
Oh, okay.
So equilateral does qualify as isosceles also. So that's the hook there. All right. And what you said about acute equilateral, actually it turns out that if you have an equilateral, the only thing it could be is acute. There's no such thing as a right equilateral or obtuse equilateral. The reason why is, and we said this in a past live stream, that the three angles in a triangle, these three angles automatically have to add up to 180 degrees.
Oh.
The thing is, you can't make three 90s add up to 180. It'll be bigger than that. You can't make three matching numbers that are bigger than 90 add up to 180 either. It'll be more than that. The only way you could do it is with three that are less than 90. And what you're going to see is if all the sides are the same in an equilateral triangle, so are all the angles. So what's 180 divided by 3 ways? 60. So all the angles would be 60 degrees. And these are all the sides are whatever measurement they are individually and stuff like that. But 60 is an acute angle. So that guarantees that an equilateral can only be acute. Scalene and isosceles can be any of the three because there are many ways you can get a right and two acutes or an obtuse and two acutes to add up to 180 and be where you have two that are equal or none that are equal. But when all three are equal, it can only be 60 degrees apiece, meaning it has to be acute.
Okay.
So that's there. Okay? So a little extra geometry on the side there. So, and it helps us fill out time a little bit better. Okay, so, all right, so let me see. All right, so, okay, this whole log -1 thing. All right. Because like I said, as I'm looking on this TI calculator, I don't see that log -1 appearing anywhere. Let me see. Okay, here, wait. Let me see something here. Because no, I do want to be able to answer this question for you. And I'll tell you right now, if I can't answer it right this second, I will definitely make sure we address it at the top of Friday's live stream. Okay, so just be back here at the same hour. Just for the record, if you could punch it, because you said you're in the Netherlands right now. What time is it locally over there? Because it's almost 3:00 here in the New York, New Jersey area here in the States. About what time is it over there for you? I want to know like how many hours forward you are, so I can have a better idea. Because I want to be able to relate my time to yours for when Friday's live stream takes place. So let me know what time. It is right now over by you. But in the meantime, let me see what I can figure.
It just comes up like that on the studio. Oh.
Let me see. Log -1 function. Okay, no, wait. Okay, hold on a second. No, that can't be right.
More math today.
Okay, here we go. Inverse of log. Let me try that. Let me see. Okay. As I'm reading it here, I just want to see. Okay. So, all right. Some functions in math have a known inverse function. The log function is one of these functions. We know that the inverse of a log function is an exponential, which is what I was saying. which is what I was saying before earlier in the thing when I compared the exponential function to the logarithmic function. So the general rule being that when you have some number to some power and it equals some amount, the logarithmic function works the other way around, where you have log of x leading to a has to equal y. So these are the inverses of one another. So this whole exponential function right here, that would be the -1 of a log function. It's okay, so it's 9 o'clock over. All right, so you're 6 hours ahead of me then. Okay, that helps me then. And please, by all means, anybody you want to spread the channel to, please hit that subscribe button, by all means, and encourage other people to do the same
right
stuff like that.
And this is where you like put the videos.
He's my little plug man here, my little hype guy.
Not in my cart. Hold it down in my cart.
Sorry about that. Yeah. Okay. Yeah. I think what's making it look. Oh no. We want to make some. Yeah, we want to definitely make some commercials and things like that. What we're ultimately going to do is both my daughter and my son, who are in 5th and 1st grade here in the States. I've got some more. We got a lot of videos for their work during the course of this past school year that we got to catch up and produce and stuff like that. We're going to be doing that very soon. Ultimately, after we do a bunch more of those or whatever, I do want to try to make some kind of general trailer for the website as well, and to advertise and stuff like. Oh, trust me, the people in my classes, they know about this. It's just a question of whether or not they choose to use it. That's the thing or whatever. I mean, occasionally a couple of my students have come by, and the stuff that you were asking me about the trigonometry, my geometry classes were doing that stuff over the past few weeks and stuff like that. So a few of them came by and were asking questions over the course of the live streams, or were asking me privately and things like that. But they know, they're fully aware of my channel and the things that I've been doing here and stuff like that. So hopefully, I was hoping a couple of them were going to come by today, because I know a couple of people had some questions about circles. Remind me on Friday. I want to make sure I get some circle questions in and stuff or whatever to help any one of my guys that are still confused. But I will say this though, Hans, I'm glad that you offered some topics today, that you asked your questions, you had things, because as I've been doing these live streams, that's the big thing that I've been wanting to do with these, as we've done these over the last 8 weeks, is to get live suggestions from anybody out there, anybody in the world that has anything in the K through 12 mathematics spectrum that they want some extra help on, or just some refreshers, or whatever the case is. So please, by all means, if you enjoyed today, first of all, if you enjoyed today, hit that like button, just to give it or whatever. And then, like I said, hit the subscribe, and please tell your friends about it. Don't even worry if they're same grade level. Anything from kindergarten through 12th grade, or at least from the American standpoint, so senior year of high school before you go to college. Okay, 17-year-olds, 18-year-olds, anywhere from kindergarten all the way up to that age bracket. If you got any math topics that you want to give, just watch, put them in. Okay, all right. Well, if there's any way to translate, I will, because I admit I have no experience in Dutch whatsoever.
And Google Translate can butcher things a lot. Yes,
I'm fully aware of that. Yes, I know Google Translate can screw things up quite a bit. But again, I'll just say this. Just if there's some way to translate exactly what it is that you want, just let your friends know to do that. And yeah, and like I said, if your friends have younger siblings that need some help on something too, same story. The one thing I will guarantee you is this: no matter what language you try to communicate to me in, I promise you this: mathematics in general is its own language, and I promise you, there is a universal translation between any language in the world. Because while I may not understand the words that you're saying, you may not understand the words that I'm saying, no numbers are the same for everybody. So it's one of those Esperantos of the world, if you want to put it that way. So listen, I appreciate your taking time out to join us. And again, so like I said, you're 6 hours ahead of me. So that means that on Friday at 8 p.m. your local time, 2 p.m. my local time here in New Jersey on Friday, I'll be back again with another live stream and by all means, please come by again. Bring your suggestions, whoever. We'll pick up right exactly from where we left off. And like I said,
yes.
If any of your friends have any, look here, they haven't really seen you. They saw Joey enough times, but okay, that's my daughter Brianna. Just so she's been. If you watch some of our past live streams, she's been helpful with a lot of stuff and bringing her own brand of silliness to the mess too. So, but we'll be back on Friday for more stuff. Come by, bring your suggestions. Have your friend Please, I would love it. It would help us out so much here as we continue to extend and try to build a brand here because we want to make this helpful to everybody in the world that we can. So I'll see you on Friday. You'll see us on Friday. Well, everybody's got their own opinions about him or whatever. I try to stay out of that department. Because personally, when it comes to politics, I hate them all. So, because neither of them can agree on anything. They all want their way, and forget it. So, all right. We'll be back, folks, on Friday at 2 p.m. Eastern Daylight Time here in the United States, or wherever you're watching in the world, find your own local time. Until then, I'm Brian. She's Brianna. We'll see you for our next live stream, and be on the lookout for more content from the channel, hopefully very soon. Take care. We'll see you.
Bye.
And thank you again for joining us.